Indexing is something which has multiple uses. The major use of indexing is to speed up your search part, to speed up your select queries. Searching, what we generally do to search, we use select star from table name. That is a basic search that we do in a database to speed up that thing, because let's say we have millions of rows. So in those rows we have only few set of columns that we require to call over and over again, that we want to search over and over again, whether we are using a join or whether we are using a normal select query, but we are searching for only those set of columns over and over again. So what we can do is, what happens actually is, every time every time when we have a set of columns which are repeatedly searched, so when a search statement is written, it searches every row. It checks out each and every row of the table. So it will go to row 1, it will check column 1, column 2, column 3, column 4, column 5. So like let's say I am searching for column 5. So it will go through all the columns 1, 2, 3, 4 and 5. That will increase the time. That will increase the search time. Understand my point? So that's how SQL works. The select statement, that's how the select statement works. It checks out each and every row for those set of columns. It will go to row 1, it will check column 1, column 2, column 3, column 4, column 5. Let's say if we need to search column 4 and 5. It will go through 1, 2 and 3 every time in every row. It will go to row 2, check row column 1, column 2, column 3, column 4, column 5. Then only it will give me the result. To speed up this process, we create indexes like the indexes that we have in our books. So we just go to the contents page, we check out, okay, this is the topic that we need to study, this is the page number, we go over there. Index is exactly the same thing. For the repeated set of columns that we are looking forward to search, we put them as indices. Index. We put them as index. So anytime when I'm searching those index, it will not search the entire table. It will go to that index part and just search those index. Then it will go to the main table and pick up those values and return it to me.
It is like a binary tree, I guess.
It is like a binary tree. Exactly. Exactly. Like we have in ML, we have a random forest function, we have a random tree forest binary tree structure. So it works in that way. Index is simply a thing to increase the speed of execution of your queries, increase the search of your queries, speed up the queries. A query that is taking like say 5 minutes or say 15 minutes to run, with indexes it can reduce it down to like few seconds. You can run that query in few seconds. What is the syntax for an index? So it's simple. Just like we create a table, we have create index. This is the keyword. Then we put the index name, whatever name that we want to give. Let's say employee underscore index or index underscore employee, whatever name you want to give, so that you can recall it. On which table I want to create an index. I mention the table name, let's say employee table. Then I enter the list of columns separated by commas, that these are the columns that I want to them to be the part of my index on which my search would be based on. That is a simple thing what an index is. That's it. Nothing more. A simple thing, a simple understanding. But there are two different kind of indices. One is a clustered index, one is a non-clustered index. That is important for you to understand. Guys, I guess it is 4 o'clock. If the call gets disconnected, please join the call again. I'll also join the call because the session is limited to 1 hour and the call might get disconnected. If it happens, please join the call back again from the same link. I'll be here only. So, this is quite simple. Just like we create table, so we create index, we give it a name, we put it on a table, on which table we want to create the index, and then we give the list of columns that we want to include as a part of our index. Fine. Now, what are clustered and what are non-clustered indexes? Clustered indexes are something, the only difference, they do the same thing. The task is the same. The ease of increasing the search operation, increase the speed of execution of a particular query. The task is exactly same what a clustered and a so um, where were we? Yeah, clustered and non-clustered indexes. So the difference is lies over here. I'll explain you. Here's the difference. A clustered index is a table where the data for the rows are stored in a relational database. If the so yeah, the main the main crux of the main difference between these two indices is clustered index, the size is large. Non-clustered index, the size is smaller as compared to a clustered index. Reason being, clustered index is something that is created within that table only. You understand my point? When I'm writing a statement, this statement, create clustered index and give index name to it, the rest remains the same, only this part changes, the clustered index. When I'm creating a clustered index, that index gets created within that table only. Just like we have a book, I have indices in that book. I have a contents page in that book. It is a part of that book. So index is part of that book. Similarly, clustered index becomes a part of that table only. There's just a mark over it. You can say there's a asterisk mark, or you can say that it a column gets registered or saved as an index within that table only. So the size increases. It is taking some memory. I have a column also, and the same column is taking a memory as an index also over there. So that's why the size is large. But when I'm talking about a non-clustered index, when I create a non-clustered index, it creates a separate table in the database. It is not visible to you, but in the memory, a separate table is created that just has indexes in it. And every index has a row number associated to it. If let's say I have four indexes, four columns, and I put them as a non-clustered index, so every column will have will have a row to it, an index to it in that index table. It's a non-clustered index. A separate table is created in the memory of the database. This table is easier to access, it's faster to access. So the size is smaller for a non-clustered index. Size becomes more for a clustered index because it becomes part of the existing table. A clustered index becomes part of the existing table. But a non-clustered index is a separate table altogether, which takes a smaller memory as compared to a clustered index. So whenever we are calling a clustered index, when suppose a table, there is a table where we created a non-clustered index and we run a select query on it. I'm talking about non-clustered index. If I have a non-clustered index created in a table and I run a query on it, it will first go to the index table. It will search out, okay, column X, which row, okay, this is the row, sorry, which index. It will find out the value, go to the table, pick that value, and return it to me. Whereas, so non-clustered index are faster. They are run quickly. Whereas in a clustered index is a part of that table only. In that table, if I have a clustered index and I run a select query, it will first search the clustered index in that table. It will be a faster one because indexes are located in a separate location in that table itself, not a separate table, but it will first have to go to that location, search that index in that location, then again search the table to pick that value what I require for that particular index or that particular column. This is the difference, major difference between a clustered and a non-clustered index. That's it. This is what indexing is. There is no limit on number of columns that you add while creating an index. There is no memory problem with creating an index. It hardly takes any memory. But better use non-clustered index. They are faster in execution. They require lesser memory. And make it a habit when you are dealing with a bigger database and when you have repeated queries that require the same set of columns to be fetched every time when you are putting a join. Let's say employee ID, or let's say department number, or let's say student ID. These are some common IDs on which you put a join to fetch data from different tables. So try to create an index on these columns so that your query will run faster. This will help you out. This will really help you out. Now, just like we alter our table, update our table, similarly you can see over there this query. You can change the name of the index. So alter index, old index name, rename to new index name. That's it. You can change the name of the index. It's something that is not required at all. See, we have alter index. I can change the index name on the table. I change it to rebuild. This is the same thing that I have given. Same thing. Yeah.
Excuse me, sir.
Yeah, yeah.
Yeah. Sir, as you said that non-clustered index is easily accessible, faster
Yes.
access. So why do we need a cluster index then?
Okay. Good question. So, clustered at times it happens like, I'll give you a nice example on this thing. So when we have so the major question is how to decide whether to use a clustered or a non-clustered index, and why
Yes.
do we require a clustered index when
Yes.
a non-clustered index gives me a better results. See, at times it happens when I have a smaller database. Let's say a bigger database, I would give you an example of like say um, 50 million rows. A smaller database could be like 2 million rows. So in a smaller database, where my search, where let's say I have only few columns that I need to work on, few columns that are running in a select query. Every time I select only, let's say only two columns in every table. So it is easier to search two columns within that table. So why not put those two columns in that table itself as an index? It's your judgment. It's at the end, it's your judgment. You can put that in a separate table as well, but again, it would be a task again for the computer because you can say it's a ratio proportion for a computer, for a SQL interpreter to run. Let's say I have 10 indices. I have created a non-clustered index. I have 10 indices. I created a clustered index. When I'll run both of these, a clustered index would take more time and a non-clustered index would give me a faster result. Now, let's say I have only two columns. I create a non-clustered index out of it and I create a clustered index out of it. I am running my queries. Both will take the same time. Then, why do I put an effort to create a separate table for a non-clustered index?
It's like less memory, more performance. Kind of that.
Exactly, exactly.
Okay.
That's the trade-off that we do. That is a kind of trade-off that we do, and that's what we have to take it on our own personal understanding how to go about it. That comes with experience. That comes with
Okay.
day-to-day experience. Better start working on non-clustered index. That makes your life much more easier, and you'll be habitual, because generally databases are of bigger size. So that's how you can play around that kind of trade-off. So this is how indexes work. Again, this is a simple thing: alter table, table name, drop index. How to drop an index? So alter table, I give the table from which I need to drop the index, I give the index name. That's it. So this is what indexing is all about. This is how normalization works. Let me just stop the recording.